Yes, thank you very much for the introduction. I will tell you more about the ATIS project in the Netherlands and how the development went during the last 30 years. Now, you already gave a very interesting introduction about myself. So yes, indeed, I studied chemistry, geochemistry. That was my second focus. That's chemistry of soil and water. And I started to work at the soil remediation company where we used electro technologies to remediate the soil. So by applying or direct current or alternating current, we could remediate organic or inorganic contaminants. And we also remediated by using bacteria. So that gives me a lot of information and understanding of how the soil works. But yeah, unfortunately, the company got bankrupted, so I had to find another challenge, which I found at If Technology. And at If Technology, I'm the international business manager, and I'm involved in all kinds of projects, partly in the Netherlands, but also international. And from the initial ideas, questions to the feasibility, design, realization, but also in the exploitation of projects. So I have done from the beginning to the end, which gives me a very nice idea of what's important and what's the impact of the design on the exploitation. So yes, you mentioned about my company Insects for All, which is indeed a company, private company, where I give guest lessons on schools, where I promote the eating of insects as a sustainable protein source. So I educate people, okay, why is it sustainable for our planet? Is it healthy or not? And always I end with tasting, which is of course the most exciting part of the guest lesson. So probably when I come to Ireland, I will bring some stuff, and we can finish also maybe an ATIS conference with some insect snacks. That will be a good idea. Thanks for the suggestion. Okay, let's talk something about the If Technology company. Our slogan is creating energy, and we are a consultant and engineering company in shallow and deep geothermal energy. So we are not a construction company, but we focus on the support of our clients from their wish to make really systems where we do the design work, the feasibility work, the supervision during installation. So all the consultancy work will be done by us. About 30 years ago, we started our the company was funded, and we started also with the shallow geothermal energy, with the focus on the aquifer thermal energy storage systems. And during the last 10, 15 years, we are now also involved in deep geothermal, but I think our strength is mainly on the ATIS technology. During a couple of developments in the Netherlands, we see that the demand for this type of systems is still growing and rapidly expanding. So in the previous presentation, I think a couple of months ago, I mentioned that we were with 75 experts, but at the moment I had to change it to 95. So in a couple of months, we added 20 experts to the company. And the experts, the advantage is that we have all kinds of experts which can help in each phase of the project. So we have the hydrogeologist, we do the research to the conditions of the soil, the aquifer properties. We have engineers in civils, in the well design, in the mechanics, in the control strategy, etc., energy consultants. So everything is in-house, which makes it very useful. And also we have some people who have a very close connection with the authorities, and they support them in the development of setting up a legal framework or how to optimize the legal framework. Now, you can see in the slides, we are present in, we are only present in the Netherlands with our head office, but in many other countries we supported clients, which could be Dutch clients doing project abroad, or it could be that we are in collaboration with other consultancy or project developers or clients in Belgium, UK, US, also do a lot of work in Japan, China, etc. And I know in the past we also had more relations also with Ireland. Let's tell me briefly about the different solutions we have in our portfolio. So on the left side, you see the BTS technology, which is the borehole thermal energy storage. In some countries, they also mention it as ground source heat pumps. But the borehole, the BTS technology is also that you really store heat and cold to reuse it in the next season, where ground source heat pumps are mostly focused on only harvesting of heat or cold. In the Netherlands, we see this technology is mainly applied for single homes or small offices. It's done, but not so on a widespread scale as it is done in example Germany. The second technology is the ATIS technology. On the next slide, I will go in more detail. Then the next one is the deep geothermal, where you use this technology as a harvest technology for harvesting heat from layers about 2,000–3,000 meter depths. Mainly used in the Netherlands for the greenhouse sector. I think about 90% is applied in the greenhouse sector, and a very small amount is just one, as far as I know, is for the residential area. On the right side, you see that a relative new technology is that we make use of the surface water energy. So the surface water is in fact a kind of big solar panel, having collecting a lot of heat during summertime, which can be harvested and temporarily stored in an ATIS well, and can then be reused in the wintertime for heating purposes. So this technology is often combined with an ATIS system. It can also be used as a kind of balancing method. So if the ATIS system is not having a good energy balance, then you can use the surface water installation for or getting more heat or getting more cold during the winter periods. At the bottom line, you see some investment numbers, which are of course very rough numbers, but at least it gives you an indication that there is some variation between the investments costs. Let's go a little bit in more detail to the aquifer thermal energy storage system. You have to take into account that this is really a battery system. So it's not primarily an energy source, but what you do is that you store the summer heat in the warm well, and that you store the cold from the winter in the cold well. So by filling this battery, you can reuse the energy in the next season. So from the cold well, let me say that the normal temperature of the soil in the Netherlands is about, I think it's the same in Ireland, about, let's say, 12 degrees. So when we look at the cold well, we see that the cold well will become about 7 degrees. So we lower the temperature by adding cold to it. There's someone who is having their microphone on. If they can switch it off, that will be nice. Thank you. From the 7 degrees well, we abstract the cold water. We exchange it with by using a heat exchanger, and then the heat from the building will be transported to the water, and the cold will be provided to the building, and then the warm water will be re-injected in the warm well with about 17 degrees. So you see that then the warm well will become about 17 degrees, and during winter time you abstract from the warm well and you can heat the building and charge the cold well by injecting the cold water. So you see that the temperature difference in the aquifer is still very small. So from 12 degrees normal temperature, you have 5 degrees smaller in the cold well and 5 degrees warmer in the warm well. So that means that the impact on the biology, microbiology, on the chemical composition, on the physics of the soil properties is nearly immeasurable. So that's a very big advantage of applying this technology. And that makes it also more easy possible that you get a permit because the impact is very small. You can imagine that when you abstract 7 degrees, that you can use this temperature for direct cooling of your building. But when you abstract with 17 degrees, it's too small, too low temperature to heat. So then you use a heat pump to increase the temperature level to about 40, 45 degrees, and then you can heat your building. So that means that the HVAC system in your building should be tuned to the way how an ATIS system is working. So that's important to take into account. So when you have a building with only radiators, it's not a very nice fit with the ATIS system. So floor heating or a ventilation system, air treatment system, that will be nice options to combine with ATIS. Now, one of the questions before the meeting was, where do you install the wells? So at least preferable from 20, 30, 40 meter and then deeper. And it depends, of course, where the aquifers are. Where will this type of systems be implemented? During till 2018, we see that especially in the utility sector, the offices is the biggest part, and a very small part in residential areas, and also in public buildings, greenhouses, hospitals. That's the biggest market. And why? Because the ATIS system has its best financial performance when you can deliver heat or when you can deliver cold. And we see that that in the office sector, in the hospitals, public buildings, there is a big demand for cold, which will now be done by air conditioning units. But if you replace them by an ATIS system, your financial performance will be increased rapidly, and that's why many new buildings where they combined the ATIS application. From 2018, the central government has decided that it is not allowed to make new buildings with a gas connection. So gas should be avoided. It's not allowed anymore. And that means that now not the economics are playing the biggest role, but just the question which technology is sustainable and is not making use of gas. And then many clients came to us and asked if ATIS is a suitable technology, and yes, it is. So now we apply ATIS also in projects where there is mainly a big heat demand. So that's a very important thing to see, that a decision of the government will has an impact on the demand for ATIS systems. Now I show you some examples. One of the oldest and biggest installations is on the left side, and the Technical University of Eindhoven, where we have about 16 cold wells, 16 warm wells, and they have installed a big thermal grid, which makes it very interesting because they started small, but during the years they expanded the grid, but then they could have their return of investment because they have already the savings, and then they could do additional investment, and they can connect during the time new buildings, and also if the grid is too small, then they add more wells to the grid. The other one is the Oostelijke Handelskade in Amsterdam, which is a combination of a hotel, a shipyard, and some residential buildings. On the right side, you see a tax office. And on this slide, you see some more projects, which shows that it's applied in shopping centers. But the Koerhuis Hotel is a very old hotel, which was completely refurbished, but they implemented the soil or the floor heating system, so they could combine it with an ATIS system. You see some residential examples, big offices like in Amsterdam, research institutes, and on the lower part you see a hospital, which is in Zwolle. It's the place where I live. Just to give you an idea, okay, where can we find this type of project and which type of applications? We started in 1989. So in the beginning, we just worked on a few projects, and then during the years, you see that the amount of system is still growing, and I have to update the numbers a little bit to 2020, but then we can count about more than 3,000 systems, and the expectation is that it will still continue. So why is it a success? Let me point out a couple of critical success factors and things where we have worked on during the last years. The first of all, of course, you need proper aquifers because you need to abstract and inject groundwater. So you should have aquifers where you can make use of. We have the advantage that we have many aquifers in the Netherlands. You can see it on the map on the left. The brown color is good aquifer and yellow is a little bit smaller. So nearly everywhere in the Netherlands it's possible, and that makes it very nice because then the technology will be accepted much more quicker because everyone who asks for an ATIS system, we could say, yes, it's possible. So that's something we also have to investigate or check also in Ireland. I show here a map. I think Belfast is somewhere on the edge. But to be honest, this picture is more related to aquifers. But when you look at the sandstone is also a very good aquifer where you can abstract and inject heat. I know that we have also done a project in Birmingham where we abstracted about 75 cubes per hour from the Sherwood sandstone, if I'm right. So I think that's good that you at least know what will be the potential in the country itself. Another issue is that what I explained is that you have a battery system. So you have to charge your ATIS system by adding cold and adding heat to the system to reuse it in the next season. So sometimes I get a question from Dubai, and then they say, oh, that's very interesting system which can provide cold, and we want to use it. But then I have to say, I'm very sorry, but yeah, in Dubai, it's always warm, so you have no time to charge your ATIS system. So yeah, and you only need cold, so that's a problem. So you see in that in climate systems where you have a C climate system or you have a D climate system, so you have moderate winters and summers, that this technology will be applied very nicely. So that's absolutely important. And as I told you before, that till now, especially cooling is driven always often the business case, because there is no good alternative for creating or making cold, and the ATIS system is in the position that it can create or provide cold for the very at a very high efficiency. I will let you show some numbers later. Good to mention also is that ATIS is absolutely not subsidized in the Netherlands. Not today, but also not in the past. Even also there's no real subsidy on heat pumps or something like that. So all the systems has been made because they want it, because it was a good business case or whatever. During the next of the presentation, I will show you some business cases so that you get a little bit feeling about the financial numbers. From the beginning, we saw that we have to spend a lot of time on the technical challenges of an ATIS system. Because the technology is in itself not very unknown, because we know that also the Chinese people applied this technology on many years before we did. But the biggest problem is that it's not the abstraction of groundwater, but is especially the injection of groundwater. And what we see in many systems is that you get clogging problems. And yeah, if the well is clogging, then you get a lot of precipitation, or the filters will become very small, and then you cannot apply your system anymore. So what we did in the Netherlands is spend a lot of time, and also together with the authorities and with other commercial companies like drilling companies, construction companies, to do research how to optimize the design of a well system. And because we are in the Netherlands, we always need a filter to prevent that all kinds of sand particles will enter the well. I know that when you go for making wells in a chalk, as we did in London, or in the sandstone, then the technology is a little bit different, because then you don't really need such a kind of screens. But when you apply it in a sand aquifer, then it is absolutely required. So then you should develop a good design of what will be the slot size, what will be the length of the filter screen, how big should be the particles just around the well. That are important design parameters which we do at the beginning of a project. What's also absolutely important is that we call it an open system, aquifer thermal energy storage, but in fact, it's a kind of closed system, because the entire piping system should be airtight. And we often abstract water from deeper aquifers, which means that the deeper aquifers are containing or having iron, dissolved iron in it. So you should prevent that any oxygen or nitrate is entering your aquifer of your ATIS system, because if oxygen is entering the system, it will react with the dissolved iron, and you get a lot of iron precipitation, which you can see on the right side, where you have on the top a clean filter. It's a camera inspection, and on the lower picture, you see where the well has been clogged by all kinds of iron precipitation. So we always pressurize our systems a little bit, so that you prevent that oxygen is entering. And we also pressurized a little bit that dissolved gases will not dissolve during the operation of your system. And finally, of course, you have to check for the right components, because we often use in the Netherlands the salinity, the salty water, because salty water will not be used for irrigation, will not be used for preparing drinking water or whatever. So it's an advantage that this is really open aquifer, not used by anyone else, so we can use it for our ATIS system. But of course, because it's a little bit salty, you have to choose right components which are resistant for corrosion. Another important or interesting thing is the drilling technique. In many countries, they are familiar with the swilling drilling, which means that you just drill. It's a more cheaper way of drilling wells. But in the Netherlands, we developed together with the drilling companies a new method, which is the reversed rotary drilling with airlifting. And the idea is that all the sediments, which I don't know if you can see my mouse, but here when you drill, you get a release of kind of sediments and clay particles, sand particles. And normally by swilling drilling, it will be transported at the borders around your drilling pipe. But then you get a lot of contamination on and the clay particles will be pushed into the aquifer. And that is not very optimal for the use of your aquifer after the drilling. So what we did is that all the sediments will be transported inside the drilling tube and then pushed here in some buffer vessels. They will sink, and then the relative clean water will be transported outside the drilling tube and go downwards. So in this way, you can drill very accurately and you can drill very clean. So that means that at the bottom, you hardly don't have a lot of contamination around your filter screen. And when you finished the well, then you don't have to spend so much time on cleaning the filter. And when you have a very clean filter, then you can use your ATIS wells for more than 30, 40, 50 years. So it has a big advantage to pay a lot of attention to a very clean and careful drilling, which is of course a little bit more expensive than the traditional way of drilling, but you have a lot of advantages afterwards. Other thing which I want to mention is that, of course, you have the commercial companies who want to implement the ATIS systems, but you have also a lot of other interests in the aquifers in the groundwater. So the authorities have to protect the groundwater, that it will not become contaminated or that it will be enough for irrigation and other purposes. But the authorities also have a goal in CO2 reduction and such kind of challenges. And what we did is that we bring the different stakeholders together, that not everyone is just thinking about his own property, but thinking together, okay, what are the main goals, the main challenges we have? So we have a challenge in CO2 reduction. We have a challenge in the protection of groundwater. We have the challenge that we want to earn money by making systems. And then we discussed, okay, how can we bring this interests together and take care that everyone can do his own job and take care for the things which are on his own property, but that you still also can make it possible that you can implement systems. So that's the way how we developed the legal framework for ATIS system during the years. And now we see that, yeah, then there is a kind of framework, and then after a couple of years it will be evaluated, etc. So very briefly about some points. In the Netherlands, it's important that you always have an energy balance. So that means that the amount of energy heat that you abstract should be equal to the amount of cold you abstract, because the authorities want to prevent that your ATIS system will be used in a way just to dump heat to the aquifers. So you should measure the amount of energy and you should prove it. You can see that on the right side by a kind of form that you say, okay, I have a balance in my heat and cold. It's not an absolute balance which should be fit 100% each year, because that's not always possible, because you have some variations in the temperature during the year. But over a longer period, they say it should be between 5 or 10, 15% balanced. Normally, it's not allowed to inject with temperatures above 25 degrees. Sometimes we have to do some monitoring of the chloride concentrations, because they want to prevent that the salty water will not mix with fresh water. But in general, the requirements for doing additional sampling is very limited, because taking a lot of samples will implement a lot of costs, which will decrease the business case or negatively influence the business case. So that's where we also find the balance, what's really necessary and what's not necessary. And finally, design, realization, and maintenance should be done by certified companies. Very interesting. I already mentioned to some people before the call is that a couple of years ago, we decided to set up a big research program. We call it meer met bodemenergie, which means do more with ETIS. Because some people were still saying we have problems with this and we have problems with that, or we think that they have a negative influence on the biology or on the chemistry of the water, or it can harm something else. So then we decided to ask a lot of drinking water companies, central government, provincial authorities, municipalities, all kind of other interest to donate a small amount of money. Finally, we collected more than €1 million to do a very detailed research to all kind of complex questions. And this is very interesting because we find a lot of questions or answers on many questions during this research. And that really helps also the business. Now, let's go in detail in some business cases. Just try to move on a little bit quickly. One of the questions I had is okay, how do you perform a project in the Netherlands? Please look at the bottom. Normally, yeah, it starts with a quick scan or a feasibility study where we go in the technical, legal, and financial aspects. We do the design of the ETIS system, the wells, but also the mechanical and controlling system. We support by asking permits for the implementation of ETIS. Detailed design can be done. We can make a tendering document and support in the tendering. We support during the realization, that we check the drawings of the construction company and that we have some periodical checks on site to improve the quality of the wells, etc. And we also do give some support during the exploitation. Now, what's in the beginning? In the beginning is, of course, the feasibility check, where you check what are the properties of the aquifer, what are the legal aspects, is there any protection zone for drinking water or not? We start to analyze the energy demands of a building, and then we can make a kind of energy concept, pre-design, and we can calculate the investment and operational cost, and of course, give you an indication of the energy performance. And we end up with the risk analysis. I won't go in all the details today, but let's start with a kind of conceptual business case. So don't pin me on the numbers at the moment, but I thought this is a very nice museum I found. So I think you recognize it. I don't, but you do probably. What we assumed is that it has a certain amount of square meters, which needs a certain amount of heat and a certain amount of cooling. I assumed some prices. And in this business case, I will compare an all-electric heating and cooling of the building compared with an ETIS system. And at the bottom, I have another concept, which is also gas with ETIS, and understood that in Ireland, often a lot of systems are just using oil or etc. for the heating, but in fact it doesn't matter too much. It gives you at least just an idea of the cost, etc. Here, do you see the amount of energy over in a year? So on the left side, it's the heating demand, and on the right side, the cooling demand ordered by all the hours each year. So you see that at 1 year in the year, you need this amount of heating, very high heating demand because it's a very cold day somewhere in February. And then during the years, you see that you have a smaller amount of heat required, and at a couple of summer months, you don't need any heating, but then you use some cooling. So that's the way how we can make it more visible how the energy demand of an building is. So for the heating, we often use or district heating systems or boilers. It could be electric, or it can also be gas or oil boilers, which will provide the heating, and you use, of course, chillers for the cooling. Now we go to the ATIS reference, and in ATIS we will completely use or provide the heating by an ATIS system, and also you can use the ATIS system for providing cold. This is one option. Of course, there are many alternatives where you make a combination between the traditional way of heating and cooling and the ATIS system. That's the way how you can optimize the cost and investments. Here you see it expressed in another way. We have the heating and cooling capacity and demand. Normally the chiller, which has an energy efficiency of about 3.5, and when you provide it or you heat them by electricity, the seasonal performance factor is about 1. Now we go to the ATIS system, same building requirements, but then you can provide directly your cold by using the ATIS system, and you can provide heat by using a heat pump, and then you can provide your heat. So you see that the efficiency is much more higher, and here the COP will be about 30 to 40, so that's really high. In this concept, we have to count with about 135 cubes per hour, or 164 in the heating mode. So then we look, okay, what will be the aquifer properties? How can we make a design of the well, and what can it produce by taking account design rules? Now, if that's fine, then sometimes you can make wells with 150 cubes per hour, but sometimes you can just have wells with 75. So then we decided to make more doublets. So that's the way how we create the concept. Let's go for the investment cost. Maybe I can spread this document later, so then you can read or check it by yourself. Conventional, you need boiler, chiller, which means a certain investment cost. The ATIS system, of course, the heat pump, the ATIS system itself will also have an investment cost. When you go to the exploitation costs, now you see the use of electricity or gas, which means that finally you use a small amount of energy, so your energy bill will be lower. When you compare it, you see that the additional investment of an ATIS system will be, now in this case, about nearly 400,000 euro, but you see that the exploitation profit is also significantly. So when you divide them, you see that the return of investment is in this case about 4 years. And that's a quite typical number we found in the Netherlands, that between 1 to 7 years will be a normal return of investment. Now, what influences the cost, the investment costs? Of course, the properties of the aquifer, because if you small aquifer or a very impermeable aquifer, then the efficiency is very limited. So that, of course, has an impact on the investment cost. The second is the energy concept, because you can make choices if you want to have a monofluent system. That means that you do 100% by your ATIS system, but you know it's a relative high investment. So making a combination with gas boilers or whatever will make an optimal investment possible. It's a little bit less energy efficient, but from a financial point of view, it's much more attractive. So that's the way how you can play a little bit and go into discussion with your client, what is most important, etc. And of course, there's a lot where you can influence on the quality, on the legal framework, how much effort needs to be done, and of course, specific conditions. Are you in the middle of the city, or are you in a greenhouse area where you have all the space to drill easily? That also, of course, influence the business. Now, here we have an additional business case, which is more related to gas. But of course, here you see some extra cost, which I did not mention in the previous one, some engineering and also probably test drilling costs. But still, at the end, you see that the investment costs are attractive, or that the return of investment is good. When you look at the type of buildings, then you will see that the bigger the building, the better performance you can have with your ATIS system. And if you have very small buildings, then ATIS is not always the preferred solution. But on the other hand, most of the buildings are relatively small, so then the ATIS will not be applied. But when you look at bigger buildings, then the grade of the amount of ATIS systems is very high. So some conclusions. Now I have mentioned them. I will just go quickly to the last slide. I think it's very important that when you want to make the ATIS business bigger in Ireland, that you have a good understanding of the hydrogeological conditions and the potential for this technology. Check how easily can you get a permit or not? Can you optimize it? Promote also the use of ATIS system in the building regulations. So if you get extra points for applying ATIS, or you get a lower energy label, that will help a lot of people to say, oh, that's an attractive way to get my points or to lower the label, which will be preferred. And also learn from our mistakes. During the last 30 years, we made a lot of mistakes, but we learned from it. And yeah, we are open to share it and and help you to make quicker steps. But finally, I think it's very important, just do it and start working on ATIS projects.